Okay, last time we done with the topic of electricity and electromagnetism. Also, we practiced the past papers questions related to electricity and electromagnetism, and there are still some questions you can practice from the topical file or from the 2024 past papers. And now we have only two topics left, and after completing those topics, we will start practicing the questions from ATP also, paper 6 for IGCSE. So the second last topic of your syllabus is related to nuclear physics. And nuclear physics is like a small section. We have very few content in that section. It is not like electricity, waves, and general physics section. These three sections are the lengthy one. In nuclear physics, mostly we know about information like information related to structure of an atom, uh, information about protons, electrons, like protons are inside the nucleus, electrons are revolving around the nucleus. So we know about the basic structure of an atom. And this is the first topic that we have to start with nuclear physics, because in nuclear physics there are only two chapters. The first chapter is related to structure of an atom, and second chapter is related to radioactivity. So starting with the structure of an atom. Okay, so basically if we talk about the structure of an atom, so as we already discussed, structure of an atom. So in structure of an atom, if we talk about electrons, if we talk about protons, so there are different models for the structure of an atom, but we don't need to study all the structures. We only need to discuss the structure that we follow for the rest of the topics. We are not going to discuss all the other structures that like are the old structure for the structure of an atom. So we only study about Rutherford's gold foil experiment and the structure that we derive from Rutherford gold foil experiment. So that is the only model we have to study in this chapter. Otherwise, we don't need to study any other model related to the structure of an atom. And in structure of an atom, we have electrons, protons, and neutrons. We already know about these particles because in static electricity we study about electrons and protons. Neutrons are neutral particle. There is no charge on it. And if we talk about protons and neutrons, so that is the part of nucleus. In nucleus, we have two particles, protons plus neutrons. And if we talk about electrons, so electrons are revolving around the nucleus. Electron revolves around the nucleus. So this is the basic idea. We know about the structure of an atom because in chemistry we also study about all these things. And one more thing, just like in periodic table, you observe the representation of different particles that we used to write in periodic table. So if we consider one example related to that, let's suppose helium. So helium is one element. In subscript, we used to write one number, and we also need to write one number in the superscript. So the number mentioned in the subscript is actually equals to the atomic number of an atom, and the number in the superscript is the mass number or the total mass of that element. So this number 2 represents atomic number, or in other words, we can say this is also called proton number. So we can easily identify the number of protons from any element. Proton number. And if we talk about number 4 written on the top of this element, so that represents atomic mass, or it is also called mass number. And this number 4 only represents the number of protons. It only represents number of protons for any specific element. And this number 4 on the top represents proton plus neutrons. So the number on the top of element represents proton plus neutron number, which is called atomic mass or mass number, and number at the bottom in the subscript that represents atomic number or proton number that only equals to the number of proton for any specific element. And if we need to find out the number of electrons, so number of electrons are always equals to the number of protons. So like in this example, for the example of helium, we have two protons. So definitely in this element, we have two electrons also. So that will remains same. So we don't need to identify electron number from the representation given in the question or given in the element. We can just identify with the help of the number of protons given in the question. So number of electron, number of electrons are always equals to number of protons. So this is the basic information. We mostly know about this information. And to find out the number of neutrons, it is also very simple. To find out the number of neutrons, we can subtract atomic number from atomic mass, because in atomic mass we have both elements given, and in atomic number we have only number of protons. So if we subtract atomic number from atomic mass, so that will give you the number of neutrons. Number of neutrons will be equals to mass number minus atomic number. And if we consider the same example, so according to the same example, we have mass number equals to 4 and atomic number equals to 2. So it means there will be 2 neutrons. So now it becomes very simple to identify the number of protons, electrons, and neutrons from this single representation of the element. We don't need to write anything individually. We can just write down this symbol in periodic table. Just like periodic table, you observe. So all elements are given. So with the help of those elements, you can easily identify all number of elements like proton, electron, and neutron with the help of this information. So this is the basic idea for the structure of an atom, general information related to structure of an atom. And the second thing in this chapter is about Rutherford gold foil experiment. There are other models also like plum pudding model, Delta's atomic model, but we only need to study about Rutherford's gold foil experiment. So basically in Rutherford's gold foil experiment, Rutherford used beam of alpha particles. Alpha particles are simply a positive charge particles. If we talk about alpha particles in simple words, so alpha particles are simply positive charge particles. And I will also share animation for that gold foil experiment to identify which apparatus and how to set up the whole apparatus for this experiment. So let's see. Because in real life, definitely we are not able to see radiations. So that's why we have to consider animated type process for all the type of experiment in which we are not able to observe radiations or we are not able to observe anything directly, just like any other object. So let's suppose in this video, you can see we have different apparatus given. So this one is the gold foil. This is gold foil. This is fluorescence screen. Okay. So in this experiment, this is the gold foil. This is screen to observe the scattering of alpha particles, because again we are not able to see the movement of alpha particle by our normal eye. So that's why we have to consider something to show the presence of alpha particles after scattering or after deflection, reflection, whatever happens after passing through the gold foil. And we have a small opening for alpha particles to enter into this specific region, and this is the source of alpha particle. So this is the source of alpha particle. And in short, we discuss alpha particles are basically the positive charge particles. So now let's see actually what happens in this experiment. Then we will discuss. An alpha particle is also radioactive. So that's why we cannot handle them in normal labs. So in this experiment, this is simple performance of the experiment. We just need to strike these alpha particle through this hole on the gold foil, and after striking the gold foil, you observe that most of the alpha particle pass through this gold foil easily. So these number of lines represents you that most of the alpha particles can easily pass through the gold foil and reach the other side. It means on the screen. So it produces fluorescence, like it produces a spark on the screen. So with the help of that spark, it leaves the traces on the screen like a white spot, just like the X-ray. So just like the photographic plate of the X-ray report. So you observe the region of the bone is white and all other region is dark. So in the same way, when you got bright spots on the screen, so it means alpha particle strike this region. So that is the evidence of alpha particle strikes the screen. And a few of them deflect with greater angle. They strikes gold foil and they deflects with greater angle. And very few of them also reflect back. For example, it strikes the gold foil and it reflect back in the opposite direction. So this is the process and this is the simple experiment performed by the Rutherford to find out the structure of an atom. Now, we don't need to write or we don't need to draw this diagram. We don't need to write the whole process apparatus for this experiment. The important thing is what we derive from this experiment, what are the results of these experiments, and what are the observations we got from this experiment. So that is the important thing because in this chapter, we don't need to explain the whole procedure. Just like in chemistry, we need to write the whole model of structure like this will happen, and from this experiment we will derive this idea. So for this experiment, gold foil experiment, so basically in gold foil experiments, the first thing is about observation. So in your exam question they will ask about observation. What are the observation of this experiment? So there are basically three observations we have to write in exams. The first one is most of alpha particles, most of alpha particles able to pass through, and second one, a few, deflected at large angle. And third important observation, very few bounce back. So these are three important information related to the gold foil experiment. Now we just need to copy paste the same observation if they ask about gold foil experiments observation in exam question. You don't need to explain or write anything extra for this experiment. So that's why these are the simple observations we have to copy paste in this question. Now, the second important thing in this experiment is what we deduce from these observations. Okay, so the second important thing in this experiment is second important heading for this experiment. What we deduce from these three observations, because most of alpha particles are passing from this gold foil easily without any deflection. So it means that according to that first observation, most of the atom is empty. Atom is mostly empty. And according to the second observation, a few deflected at large angles. So why they deflect at large angle? Because we discussed in the start of the structure of an atom, in the middle of the nucleus, like in nucleus, basically we have protons and neutrons. So protons are positively charged. So when alpha particles are itself positive charge particles. So when positive moves towards the positive charge, so they starts to deflect or they starts to repel from the positive charge. So the second information that we derive from this experiment is a very small and very dense positively charged nucleus exists at center. So from this experiment, we derive this idea that alpha particles are positive and they deflect from the center. So it gives you the idea that something is also positive in the center of an atom. And according to the third observation is very few bounced back. So very few bounced back means that electrons exist around the nucleus. So this is the third point Rutherford derived from the experiment of gold foil. And the third important heading is about the reasons, like why this happened, because right now we only mentioned the point that we derive from this experiment. And the third important heading is about reasons, like why it is happening in this pattern. So if we talk about reasons, so the first reason is definitely atom is mostly empty. So because of the empty region, it easily allow the alpha particles to pass through the gold foil. Empty region of atom allowed alpha particle to travel undeviated. Number two, uh, some alpha particles also approach the center of the gold foil. So when they approach the center of the gold foil, so definitely because of positive charge, because of repulsion, they it starts to deflect from the center. So those alpha particles that approached closer to nucleus deflected due to repulsion. And the third one is very few directly strikes the center, exactly center of the nucleus, like head-on collision that bounce back, approached head-on to the nucleus. So these are the reasons that why alpha particles behave like the pattern we discussed. So this is the simple reason. Because of this, alpha particles deflect through large angles and they also bounce back because of the force of repulsion between the positive charge of the nucleus and positive charge of alpha particles, and electrons are not available in the nucleus, they are revolving around the nucleus. So this is the experiment, and these are the headings that we need to remember related to Rutherford's gold foil experiment. Any question in this?
No.
Okay. And we have one more topic in this chapter, because this chapter is, and the topics in this chapter are very limited, very short and to the point, because in exam question, when you solve the exam questions, so you will observe also that questions are very similar, and those questions are from the limited topic, because the structure of an atom is very limited in physics, because we already study this concept in chemistry also. So if we include all the detail over here, so that same information is available in chemistry also. So you will study like same thing in two different subjects. So that's why we only need to study about few concepts which are important for radioactivity chapter, because the next chapter is radioactivity. So before radioactivity, we need to know about the basics of few things. So that's why these topics are included in the structure of an atom. The next topic is about isotopes. And definitely you know about isotopes. What are isotopes? So if you consider like any specific type of element, so there are different variations of the atoms of the same element.
Of the number of neutrons.
Yes. So basically only the number of neutrons are different, but their number of protons are same. So basically isotopes are atoms of same element. And second, we have same number of proton, but different number of neutron. So this is the same definition we used to write in the other chapters of chemistry. And in your physics past papers question, you observe they also ask about the definition of isotopes. Because from structure of an atom, when we observe different questions related to different elements, so they used to ask like, what is the difference in the structure of this element to that element? So then we identify the number of protons and number of neutrons. So that's why this topic is important to study in this chapter. Otherwise, we have to take a reference from chemistry all the time, like in this chapter, you study this thing or not. And for example, if you consider some past papers question related to this topic, you can see we have only two chapters: nuclear structure of an atom or radioactivity. So MCQs are very straightforward. Which statement about a nucleus of this element is correct?
C.
Option C, 7 protons, 8 neutrons, right? So it is very simple to identify, because this represents proton number, this represents proton plus neutron. Option C, and these questions are from the past papers. The next one is, now they use different types of diagrams, different phrasing, but again concept remains the same. So these diagram represents the nuclei of three atoms. So what are isotopes? of same element,
P.
P and R. Okay. So in P and R, we have same number of protons. These dark one, 2 and 2. Correct. Okay, this is related to decay. We will discuss this concept in radioactivity chapter about decay. Okay, this is also related to decay. Okay, number 5. In GM experiment, Giger-Marsden experiment, this is also the same thing, Rutherford experiment. A beam of alpha particle, because to measure nuclear radiation like alpha, beta, or gamma, we use GM tube. So that's why they also name this experiment as GM experiment, Giger-Marsden experiment. A beam of alpha particle is fired as a very thin sheet of gold foil in a vacuum. So what is deduced from this experiment?
P.
Uh, Atoms contain air.
No, D. D.
The nuclei are much smaller than atoms. Okay. Okay, now we have carbon. It represents the nuclide of element carbon, and this represents a nitrogen. How does a neutral atom of nitrogen differs from a neutral atom of carbon?
D.
So basically, again, you have to count the number of protons and number of the neutrons. You know that we have one more proton in nitrogen as compared to carbon, but their proton neutrons combined number are same. So the nitrogen has one more proton more than carbon. C is not correct. So D is the right answer. Nitrogen atom has one proton more than the carbon atom. Okay. A neutral atom of chlorine 37 is compared with a neutral atom of argon 37. So how do the number of electrons and number of neutrons in each of the atoms compare? So now we have two elements, and these two elements are of like same number 37, 37, and both are neutral atoms. So how do the number of electrons and number of neutrons in each of the atoms compare? So basically this 37 represents proton plus neutron number. So from this like atomic mass, we are not able to identify exact number of protons and exact number of electrons, right? So it depends uh, upon the element, like what are exact number of protons. Because without number of protons, we are not able to identify number of electrons. And from this atomic mass only, again, we are not able to identify exact number of proton or neutrons. So that's why we can say number of electrons and number of neutrons both are different, right? Because from this specific information, it is difficult to identify exact thing. Number 11, which nuclides have the same number of neutrons in a nucleus? In option A, we have 5 protons, then 7 neutrons. Over here, we have 6 protons, 6 neutrons. It means option A is not possible. Then we have 1 proton, 0 neutron. 1 proton, 1 neutron. This is also not possible. Then in option C, we have 6 proton, 6 neutron, 7 proton, and 6 neutrons. So now in this option, we have same number of neutrons, C, because they are talking about same number of neutrons. So in option C, we have same number of neutrons because number of protons are same in option B, but number of neutrons are same for option C. Number 12, again in gold foil experiment, a beam of alpha particles is fired at a thin sheet of gold in vacuum. The majority of the alpha particles pass straight through the sheet without being deflected. So what does this show? So basically, it shows you that nucleus is very small, because if nucleus is greater in size, so definitely it will not possible for alpha particles to pass through easily without any
D.
deflection. So that's why D is the right answer, because this is the only option that gives you that most of the atom is empty. Okay, number 13 is related to isotope. The compositions of 4 nuclei are shown in the table. Which 2 nuclei are isotopes of same element? So we know that same number of protons, 88, 88, right? So definitely when we have same number of protons, so that is the information related to isotope. Because R, S, P, Q, only P and Q are like having same number of protons, other are having different one. So P and Q. So these are some questions related to the structure of an atom, and you can see that they are asking the same thing again and again. It is not like they ask only for 1 or 2 times. You will find that most of the MCQs are of same pattern, and also they are very few. And next time we will start the next chapter from this nuclear physics, which is related to radioactivity. Radioactivity is the second topic, which is important than this is structure of an atom, because this is almost like the same thing you know about it, but we only need to identify which things are important to write in the exam and which concepts are not important according to the exam's point of view. related to the structure of an atom. So inshallah next time we will start with radioactivity. Okay.